Hello, today we're going to do convert sorted array to binary search tree, which is LeetCode problem 108. So if we look at the problem here, it says given an array, an integer array nums, where the elements are sorted in ascending order, convert it to a height-balanced binary search tree. A height-balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one. So let's look at the first example. We have an input array nums of -10, -3, 0, 5, and 9. And the output is 0, -3, 9, -10, null, and 5. What does that even mean? Oh, they have an explanation. Great. 0, -10, 5, null, -3, null, 9 is also accepted. That is not an explanation. It is just there to confuse us more. So let's go back and try and unpack what they're talking about. So first, let's talk about the different ways to traverse a binary tree, and there are three different ways. First is called the left root right, which is basically going to start with the lowest left node and work your way back up the tree. So -10, then -3 is the next left node, then 0, then we're going to jump down to the 5, because that left comes before right. If I was on the right side, I'd be upset that the left is always more important, but that's just the way it is. So left is 5, and then we take the 9. Now pre-order traversal, root left right, and this is a dead giveaway because the pre-order traversal always starts with the root node. So we have 0, -3, 9, -10, 5. So top down. And finally, we have the post-order traversal, which starts with the left, then does the right, then does the root. So you have -10, 5, -3, 9, and then finally 0. So let's go back to the problem and see if we can't figure out what they're talking about. Okay, so the output. Now, because it starts with 0, we're using the post traversal. So 0, -3, 9, -10, and then it has a null here because the -3 doesn't have a right side. And then the 5. And we don't. Once we get done with the left there, we don't. If the last branch is 0, then we don't care, null. Now, this is also accepted. So 0, -10, 5, and then null because -10 doesn't have a left branch, -3, null again because the 5 doesn't have a right branch, and then 9. And so the way we're going to build this is we're going to get this second tree here. So let's see how to do that. Okay, so this is the method that LeetCode gives us. We're going to input the nums array. First thing we're going to do to check to see if nums array is null or if the length is 0. Then we're just going to return null. Else, you guessed it, we're going to use recursion, and we're going to build the binary sort tree. Passing in the nums, we're going to pass in the left value, and we're going to pass in the rightmost value, which will be nums length -1, accounting for zero-based indexing. And so now we need to build that build BST method. So we're going to pass back a tree node. We're going to have the int nums, int left, and int right. First thing we're going to do is check to make sure the left is less than right. Otherwise, we need to return null. Then we're going to define a midpoint, which is going to be left plus right divided by 2. Now, we're going to create a tree node. We'll call it current, new tree node, and we're going to use the midpoint of nums. And then we need to check to see if we have a left value. So we're going to call build binary sort tree again, passing in the nums array the same left value. And because we're checking for a left, we're going to take mid -1 for the right value. So we'll go through that until we've done all the left nodes, and then we'll come back and do the right node. So we'll call binary sort tree, passing in the nums, and then we'll take the left value and add 1. We'll make it the mid value plus 1, and then right. And then finally, we'll just return current. Now, let's look at this in the debugger. I think that will clear up some of the confusion. All right, I got my little diagram here. All right, so this is what we're trying to build here, and we've been given the nums array. This is the first example: -10, 3, 0, 5, and 9. All right, so let's start going through this. Actually, before we do that, I don't know if this matters. There was one other example too, which I don't. Input nums 1, 3. Output is 3, 1 or 1, 3. So either one will work. That really, I guess. Did not need to go back and do that, but whatevs. All right, let's see here. Let's get that back. All right. So the first thing we do is we're going to check that nums is not null, which it isn't. Then we're going to build the binary sort tree. All right. So we've got a left value of 0 and a right value is 4. So the length of the array is 5 minus 1 is 4. Left is not greater than right, so we're going to assign a midpoint. Left plus right divided by 2 gives 2. So now we're going to create a tree node with the midpoint, which is 0, 1, 2. So this will be the root node. Create that. Bam, there we have it. Current, value 0, no left, no right. So now we're going to see if the 0 has a left node. So we're going to call build sort, or build binary sort tree again, and we're going to decrease the right value by 1. So left is not greater than right. The mid is going to be 0 because 0 plus 1 is 1 divided by 2 is 0.5, but we can't have only have whole numbers for integers, so it rounds down. Okay, so now we're going to create a new midpoint for that, which is the -10 over here. And we're going to check to see if it has a left. Well, it doesn't because the left was greater than the right, so it returns null. So okay, we'll say, okay, so now we're going to see if it has a right value. So we'll do mid plus 1, which gives us 1, and the right is 1. Midpoint of 1. 1 plus 1 is 2, divided by 2 is 1. So now we're going to grab, this is going to build the -3. Okay, so now left is greater than right. We're checking to see if the -3 has a left node, and it doesn't. So now if you look here, we're back, we're still on the -3. So I'm sorry, we're checking if there's a right value to the -3, which it won't find that either. Okay, so now we're just going to return the current, which is the, oops, over here, -3. Okay, so what we just did was return -3, which brought us back to the -10. And the -10 returns current there. Now we're back to the 0, because we've gone through both the left and right on -10. Current left, we've gone through all the left portion of the tree, so now we're going to go to the right. Left 3, right 4. The mid is 3, 0, 1, 2, 3. So now we're going to take care of the 5. Let's see, the 5 has a left. Left is 2, so the 5 does not have a left. So we'll go down to the right. Left is 4, right is 4. Looks like the 5 has a right. So we'll create a new current tree node, which will be 4. The midpoint will be 4. So 0, 1, 2, 3. Index 4 is the 9. All right, so this, let's see here, blah, blah, blah. The 9 doesn't have a left. We're still on the 9, right? Yeah, 9. And the 9 doesn't have a right branch. So we're going to turn that. Boom. And now we're on to the 5. And so now we've done the left on the 5. There wasn't anything, but we return the right. And now we're back to the 0. And see, the 0 has a left, which is the -10, and it has a right, which is the -3. So now we're going to go to the right side of the 0 node. And we're going to return right, and okay. yeah, so I got confused there for a second. So we just did the right side of the 0 node, which passed in the 5 and the -9. So that is the answer. If you see there, this 0 has a right value of 5, and the 5 has a right value of 9. And that is the answer. Fun with recursion in binary trees. All right, so let's run it through LeetCode. Run this. Is accepted. And we'll submit it again. Fastest submission. LeetCode submissions do not lie. All right, let's finish this out here with the time complexity, O of n, where n is the number of nodes. As you add more nodes, it's going to take longer. And space complexity is actually O log of n because the tree is height balanced. So the more nodes you add, it's just going to take slightly more memory. And that is it. So once again, thanks for watching, and let me know if you have any questions, and we'll see you next time.